Now we are doing the converse of Pythagoras theorem. If you remember, Pythagoras theorem is a property of a right angle triangle which says that the square of the hypotenuse is equal to the sum of the squares of the other two sides. So what could be the converse of this Pythagoras theorem? The converse of the Pythagoras theorem goes in the theorem 6.9. It is given here, stated. It will be the converse. It means if you are given a triangle of property, having a property that square of one side is equal to the sum of the squares of the other two sides, then the angle opposite that first side must be a right angle. See, theorem 6.9 says, in a triangle, if square of one side is equal to the sum of the squares of the other two sides, then the angle opposite the first side is a right angle. It says this way. If there is a triangle, we don't know whether it's a right angle triangle or whatever it is. If this is a right angle triangle and you are given that square of this side, if this is say ABC, if you are given AC square is equal to the sum of the squares of the other two sides, it is equal to AB square plus BC square. You are given this side square is equal to this side square plus this side square. Then, as per this converse of Pythagoras theorem, the angle opposite to this side, which is equal to the sum of the squares of the other two sides, must be the opposite angle opposite to this. This has to be a right angle. So we will prove this theorem, converse of Pythagoras theorem, theorem 6.9. Theorem 6.9. We are going to prove that. You just try to read it and try to understand again. So theorem 6.9 is stated, and now we have to prove it. When it comes to prove, you are not supposed to prove it directly. You will be given the data. You will be given the data and you will be given what to prove. So data will be like this. In this case, what will be given is that in triangle ABC, we have this triangle ABC, and in this triangle ABC, AC square, square of one side is equal to the sum of the squares of the other two sides. And what you have to prove is that angle B is equal to 90 degrees, or angle B is a right angle. Now simply with this triangle alone we cannot prove this theorem. We have to take one more triangle. So there will be a construction, and so you may be given the construction also, and construction is like this. You are drawing another triangle such that take triangle ABC or PQR. You are taking another triangle PQR such that QR is equal to BC, PQ is equal to AB. And in this triangle, additional thing is angle Q is equal to 90 degrees. It's given. Angle Q is 90 degrees. You will mark it. You are given that this is a triangle where PQ, QR are same as AB, BC, and this angle is 90. So what we are going to do is, we are going to prove that this triangle has to be congruent to this triangle, is congruent to this triangle, and thereby we will get that angle B is also 90. Now see, the moment we have this side equal, this side equal, doesn't make this triangle congruent to this triangle, because this could be any side, and if this is not 90, then how can it be congruent to this? So we do not know this angle, so we do not know whether this triangle is congruent to this triangle. So what we have to do is show the triangles congruent. So proof is like this. In triangle ABC and triangle PQR, in these two triangles, AB is equal to PQ, we'll write it in one statement itself, and BC is equal to QR. This is given by construction, or if they give it, you may write given. So this triangle is constructed in such a way that AB equal to PQ, BC equal to QR. So these two are equal by construction. Now we know that you are given a property for this triangle that AC square is equal to AB square plus BC square. This is given. So let us now replace, in the place of AB, of this statement, in the place of AB, we know that AB is equal to PQ and BC is equal to QR. So in this statement, we are changing. In the place of AB, we are writing PQ square and BC will replace by QR. So we can write here QR square from step 1 and 2. First we wrote this. This is our step. In this step, we are replacing AB, BC by this because we know that AB is equal to PQ, BC equal to QR. Why we do this? Because ultimately what we want to do is show that AC and PR are equal. So once we know these two are equal and once we show AC is also equal to PR, all the three sides equal, means the two triangles are congruent. You know the test, congruence test, SSS congruence test. So what we can do now is AC square is PQ square. Okay, this is there. But in this triangle we know, because this triangle is a right angle triangle, not this one. This one is a right angle triangle. And right angle, if it is a right angle triangle, we know we can apply Pythagoras theorem. Pythagoras theorem is applied in a right angle triangle. So what is that Pythagoras theorem which we can apply here? We can say that PR square is equal to PQ square plus QR square by Pythagoras theorem. So we'll write that PR square we know is equal to PQ square plus, see, we are getting the same thing on the right side, by Pythagoras theorem. Which triangle it is? We are applying this in triangle PQR. We are applying Pythagoras theorem in triangle PQR. We get PR square equal to PQ square plus QR square. Now see these two statements. Here we have AC square is equal to PQ, QR. PQ square plus QR square. Here we have PR square is equal to PQ square plus QR square. See, both are same. These both are same. And AC square is equal to that, PR square is equal to that same thing. That means, obviously, therefore, AC square is equal to PR square. From step 3 and 4. Obvious. And we know that if squares are equal, the bases are also equal. Because these are not negative, cannot be negative. So both has to be positive because they are lengths of sides. So their squares equal, that means their bases are also equal. AC equal to PR. We got AC equal to PR. We have here a statement saying AB equal to PQ, BC equal to QR, and we got now AC equal to PR. So, shall we write all these three together? yes, we can write additional step like this from this. Yeah, therefore in triangle ABC and PQR again, some people writing all the steps again. We will not just do that. We'll write briefly. In triangle ABC PQR, we have AB equal to PQ, BC equal to QR, AC equal to PR. From step 1 and 6. So we got all the three sides equal, therefore we know, therefore triangle ABC is congruent to triangle PQR. See, in this lesson, only the first time we are showing congruence, you are using congruence. Otherwise, we always use similarity. Here we are using congruence. Remember that. Don't write similar triangles. Triangles are congruent by SSS congruence rule. And why we proved this triangles congruent? So that we can compare these two angles, because these two triangles are congruent, and this is already 90 and these are congruent, therefore this must also be 90, because corresponding angles always are equal for a congruent triangle. These two triangles are congruent, therefore angle B has to be equal to angle Q, CPCT, and it is equal to 90. Therefore angle B is equal to angle Q, which is equal to 90 degrees. Reason CPCT. So we got angle B as 90 degrees. If they had asked, show that the angle B is a right angle, then you may write the last additional statement that angle B is a right angle from here. But here they have asked angle B, you prove that angle B is 90. So this would be the last step. So what we have done here is, we have proved the converse of Pythagoras theorem, which says that if in a triangle, square of one side is equal to the sum of the square of the other two sides, then the angle opposite this side is 90 degrees. We have proved.